Hello everyone. Today I'm going to answer something that some of you all asked me. In the last video, we had a peak velocity formula this, and I didn't derive it. I didn't show you how it comes from. And we're talking about Maxwell velocity distribution. So this is the Maxwell velocity distribution of the speed of molecules. So this is the component. If the velocity is v, speed is v, then it will have some x component, and so if this is projected like that, this will be along the x direction vx, along the y direction vy, and parallel to that 90 degrees over here, this will be vz, z direction. So that's in the velocity space, so to say, and you can convert this volume into this volume using a spherical coordinate in this space, right? So that you can talk about speed instead of velocity. So we are the peak velocity refers to you can see this whole thing where this is maximum if where the peak velocity occurs. Okay, so this, if you call it fv, so what this fv represents, so if I say fv is fv is m over 2 pi kb t 3/2 times 4 pi times v square e to the minus mv square over 2 kbt. It is a probability density. So the fv is speed probability density, and if I multiply by dv, so fv dv multiply dv, this is the probability that the speed of a molecule picked randomly, right, in n molecule, say gas, okay, is between v and v plus dv, and the v here is, it's going to be between 0 and infinity. So when you integrate this, if you integrate fv dv, you will get 1, because the probability will be 1 for going from 0 to infinity, right? So that's where all of these factors come in. All right, peak is the peak v, that is v sub p is speed v when fv is maximum. So because v is only in here, you can see that v square will be going this way, and this is exponential, so this thing will be going that way. So this will be e to the minus v square, alpha v square going that way. So the net effect of this whole thing is start from 0 here, is going to be like this, and so there will be a peak, and that's the vp, and this is v square e to the power minus alpha v square, and alpha equals to this m over 2 kbt, m over 2 kbt. So just like any other, you can see this is all independent of v. let's call it some c. So fv is some c v square e to the minus alpha v square. And you want to know what's the maximum. You could do, so the one way you could do it, df dv equal to 0. And that can solve for v. That's one way. But another way is take a log of this, log of fv, because it's all exponential, so ln, and so d ln f dv equals 0. Now these will be same peaks. Why? Because f and log f is a monotonic function. So if you look at f, some function y and y, some value y and log y, well, log y will just monotonic increasing function. So as y increases, log y increases monotonically. It's not like sine of cosine. It's not like going like this, you know. So it's monotonically increasing. So wherever peak of this is, where the peak of that is, and it's very easy to do in this thing. So I've got a log of c, log of f, log of c, plus 2 log of v minus alpha v square, right? And so d log of f dv equal to 0. This gives me 0. This gives me 2 over v, and this gives me 2 alpha v, and that's set equal to 0. And to solve that, 2 goes away, so v square equals to 1 over alpha. V square equals to 1 over alpha, and that means, and v is positive, so v is equal to v at the peak. V at the peak is 1 over square root of alpha. Is square root of alpha is 2 kb over m, 2 kbt over m. So that's the derivation. Hope this clarifies. Maybe in another video I might have said fv was just this. No, fv is this whole thing times this. So this is all constant. Not constant as far as v is concerned, but has m and has a t over here. But as regards to v, speed, this part can be considered constant. And calculation gets simpler when I convert that into a log. Taking derivative of log much easier than if you go out and do that. Of course you could do out and do that. Okay, so for you, show df dv equal to 0 gives same answer. Just do directly with this instead of doing the log. Okay, that's it. Take care. Bye.